Okay, let's trace a single drop of blood through the heart. Deoxygenated blood is going to enter the heart on the right side into the right atrium. Okay, so deoxygenated blood will enter through the superior vena cava, and here's the inferior vena cava. And we know that there's no valve that's guarding that entry. Okay, so blood is going to enter in from the body into the right atrium. In order to exit the right atrium, that blood is going to have to flow through the tricuspid valve. So there's the tricuspid valve into, here's the right ventricle. And then in order for the blood to exit the right ventricle, that blood is going to have to exit through the pulmonary semilunar valve. And the pulmonary semilunar valve leads into, this is the pulmonary trunk, and then the two pulmonary arteries that are going to go out to the right and left lung. And so that deoxygenated blood is being sent from the right side of the heart to the lungs. Once that blood becomes oxygenated, that oxygenated blood from the lungs returns to the heart on the left-hand side into the left atrium, and there's no valves that guard that entry, so blood would enter into the left atrium, and then in order to get into the left ventricle, that blood would have to pass through the bicuspid valve. So blood would flow through the bicuspid valve into the left ventricle, and then to get out of the left ventricle, remember there's one exit, that is the aortic semilunar valve, and the aortic semilunar valve leads into the aorta, and that's carrying oxygenated blood out to the body. Let's take a look at this picture that I gave you in the notes. It goes through the same idea. They're showing us that the vena cava returned deoxygenated blood at the level of the right atrium. Blood is going to flow through the tricuspid valve into the right ventricle. To get out of the right ventricle, the blood is going to flow through the pulmonary semilunar valve into the pulmonary trunk, out the pulmonary arteries, and the pulmonary arteries are going to the lungs. Once the blood enters the lungs, it's deoxygenated, but by the time it flows through the lungs, it becomes oxygenated. That oxygenated blood is going to return to the heart at the level of the left atrium. Oxygenated blood enters into the left atrium, passes through the bicuspid valve into the left ventricle, and then out the aortic semilunar valve into the aorta, and the aorta is going to carry oxygenated blood out to the body. As that oxygenated blood flows through the capillary beds of the body, becomes deoxygenated, and that's the deoxygenated blood that will return to the right side of the heart. So you can see that there are two circulatory routes. The right side of the heart is sending deoxygenated blood out to the lungs. That's called the pulmonary circuit. And then the left side of the heart is sending oxygenated blood out to the body. That's called the systemic circuit. Okay, let's mark up the notes on the path of blood flow through the heart. And what we're doing here is if we were to trace a single blood cell through the heart, what would its journey be? The right side of the heart is the pulmonary circulation. Deoxygenated blood from above and below the heart will enter the right atrium. That deoxygenated blood is going to flow through the tricuspid valve into the right ventricle. That deoxygenated blood is going to exit the heart through the pulmonary semilunar valve, enter into the pulmonary trunk, and then the pulmonary arteries that carry that blood out to the lungs, and that's where the blood is going to become oxygenated. After the blood is oxygenated, that blood will return to the left side of the heart. This is known as the systemic circulation. Oxygenated blood from the right and left lungs return to the left atrium through the right and left pulmonary veins. That oxygenated blood will flow from the left atrium through the bicuspid valve into the left ventricle. The oxygenated blood will exit the left ventricle through the aortic semilunar valve into the aorta and then get distributed throughout the body.